today I'm going to be talking about Tezos X. I'll get to the next slide of what it is. But what it does is that it opens a new frontier for all developers. So what is Tezos X? So Tezos X is a proposal, and that's important to understand. Tezos does decentralized governance. We actually have decentralized governance. It's going to dozens of upgrades now, over a dozen upgrades, and all of them have been voted by the stakeholders of the chain. It doesn't evolve by a hard fork. It doesn't evolve by a centralized team, dictating what should happen. It's all decentralized, and so Tezos X is a proposal for Tezos. So what is it? Well, first, it's modulitic. I'm not a fan of the neologism, but it says it. It's both modular in approach, so it's a modular design, but you get all the benefits of having a monolithic approach, all the composability. So you keep the performance of being modular, but you keep the composability of being monolithic. You get the best of both worlds. You keep the interoperability. And what do you get in the end? Well, the goal is to get something that's almost like a cloud-like backend, where any application you could build on a cloud, you could just go and get your cloud account and run your software. The chain, if it's just so performant and so cheap, you can just treat it as a cloud. And that's the goal. That's where we want to go with Tezos X. So how does this work? What are the different layers? How is it monolithic? So you start with a platform, and the platform on the L1, that's your base. That's where you have your governance for deciding what's going to happen, for deciding how the chain should evolve. That's super important. I don't think you can have a decentralized chain today without on-chain governance. Otherwise, what you have is a software company masquerading as like a ledger, and it's not a good foundation. You have your consensus, super important. At the end of the day, why do we have blockchains? We have blockchains because we want to have a record, a ledger, and you need to have consensus to record transactions. Staking, so staking is what allows the consensus. The settlement, and you need to have fast finality if you want to have really good settlement guarantees. And potentially bridging also with other ecosystems, because there are now hundreds of blockchains out there, and bridging has become quite important. On top of that, you build a data availability layer. So data availability layer, of course, there's been a lot of hype around them, with many people building different type of data availability layers. You've seen them with Celestia. You've seen them with the blobs in Ethereum, and the promise of dank sharding. So we have a data availability layer on Tezos. You can try it today. It's currently optional for the validators of Tezos to run it, but it's becoming a full part of the protocol very soon, and it's based on the full sharded data availability sampling approach. You can build on top of that low latency sequencers. I've given a lot of talks on what sequencers can do. The long and short of it is, if you look today at sequencers, I think the term has been bastardized because a lot of people use them as a crutch for centralization. They'll run a rollup. They'll say oh, come in, go on chain, go on chain. But you're not going on chain at all. You're going on some corporate company's private database, and their sequencer does everything. It controls the security, it controls your assets, it can steal your asset, it can do everything. So those are not the sequencer we're talking about. We're talking about very, very narrow sequencers that do one thing and one thing only, which is decide on the order of the transaction, so that you can get confirmations very, very fast, so that in less than a second, you know that your transaction is going to be sequenced, is going to be integrated in the chain, and they have no other powers than that. They cannot steal money. They cannot control the security of the chain. So be wary. There's a lot of L2 solutions which are just private databases masquerading as L2s. That's not what we're talking about here. Then you have a smart rollup engine. So we started with a Mumbai upgrade in Tezos last year with WASM. So anything that you can compile to WASM, and many languages compile to WASM. Assembly script, Rust. Anything that compiles to WASM today, you can run as a smart rollup on Tezos, but we're adding more. So we're adding RISC-V support, which I think is an even broader compilation target than WASM. There was a while back, if you follow the trends and the vibes a little bit, where the crypto industry was all about WASM. Now it's shifting more towards RISC-V. And we're following this. It's not just because of hype. There are a lot of benefits to this architecture. Fraud proofs, obviously, we wouldn't run any of this without fraud proofs. I think it's a complete travesty when people are doing L2s and they don't have fraud proofs. And also zero-knowledge proofs. Love zero knowledge. I wrote a blog post in 2017. I encourage you to check it out. It has held really, really well on how you could build ZK rollups essentially to scale. and to provide a lot of throughput. I think it holds to this day, but the cost of decay is still very, very high. I think it's fallen to the point where if all you're doing is just like regular transactions, you're going to be fine, even like some smart contracts. But if you want to build a true cloud-like backend where you can just run any application, where you can compile it and you don't have to like gas optimize everything, then we're not quite there yet. But I think it'll be a drop-in replacement if and when we get there. Runtimes, that's, what do you build on top of that? So, Mikkelsen is the original runtime on, for Tezos. It's a VM. It's an awesome VM. If you want to do formal verification of your contract, it's super important. But what happened? Well, the first thing is like people really don't like doing formal verification. It's very, very time consuming. And second, a lot of applications have been quite centralized. People have been happy having centralized applications. So if your application is centralized and you have keys where you can upgrade your contract, and if formal verification is still very time consuming, then maybe you're not going to bother. But I think that's changing. One is because AI is making formal verification much more automatable now. The long and short of it is that formal verification is tedious, but not intellectually very complex. It's just that you really need to like slog through a lot of effort to do it. That can be automated. It is being automated. And the second thing is like, I think over time, we're going to see things change out. Systems which are centralized are more brittle. The keys get stolen. They get fines. They have to comply. Whereas systems which are actually decentralized are more useful. So I think we'll see some of that. But for now, the EVM is also a very, very popular system. And we've built on top of Tezos Etherlink, which is a layer 2 solution. It's 100% Ethereum compatible. You can use it today. It's not properly launched, but it's on mainnet. It works, so try it out. And it's fully EVM compatible. Lots of demand for EVM, of course, in our industry. But you can go much beyond that. And I'll talk about that, including, for example, JavaScript as a runtime. What do you build on top of that? Languages. So JavaScript, it's a language in itself, so it can be a VM and a language. But languages that we've known and loved in the Tezos ecosystem, like LIGO, SmartPy, and also more popular languages out there, like Solidity, a little bit more popular, and massively more popular languages like Python, Java. Those have orders of magnitude more developers than any of our blockchain programming languages. And on top of that, what do you build? Great applications in the DeFi space, gaming space, in art. So many possibilities. So what are the key deliveries of this Tezos X thing? I went a little bit through the stack. Interoperability is a huge factor. And so I've mentioned support for Solidity, which we introduced now on Tezos via Etherlink. But Solidity is small. You're talking about thousands of developers. Python, Java, JavaScript, C#. Those have millions, tens of millions of developers. They have libraries. They have these deep toolchains, these deep ecosystems. And despite the billion that have been spent trying to make Ethereum work and trying to make Solidity work, like this ecosystem of Python and JavaScript has had way more development at it, way more support. Interoperability means interoperability in terms of code. You want to be able to reuse those libraries. You want to be able to reuse this human capital that exists out there. But it also can mean integration with other chains, but also non-blockchain system. Now, what powers this interoperability is performance. I would say a lot of early languages, a lot of early VM like Mikkelsen are very, very concerned with performance because blockchains were extremely throughput constrained. You couldn't do all that much. And so your language had to be like really tailor-fit to doing smart contracts and doing these operations. But if you can, if you want to be able to just compile some code and run it and not have to worry too much about performance, then you need to have a lot of performance in your backend. So the target is 1 million transactions per second TP throughput. We've demonstrated that already. So last year at TesDev, the Tezos Developer Conference, we demonstrated 1 million transactions per second on-chain, but that was in parallel across 1,000 rollups. So that's a modular approach. The modulistic approach is we want 1 million TPS in a single rollup with sub-second latency and less than 10-second finality. So that's the key deliverable for Tezos X. Finally, composability, no fragmentation. No one wants to be jumping between 10 different rollups, moving their assets around via bridges. No one wants to have to decide where they're going to be their contract, because if I build my contract here, it's not going to be able to access this other ecosystem. And so you want the flexibility of just being able to compose with any other contract that's being deployed and enforce atomic operations across those contracts. So we could call it Tezos broadband moment. It's a difference between the dial-up, where you can go to a few websites and you can get some information, you can read a few things online, to broadband, where the web stops being just an information content delivery and become an application content delivery, where essentially the browser has replaced the operating system as a way to deliver applications today. You very rarely now, unless for like some very, very specific, like resource-heavy applications, rarely do you install applications on a computer anymore. It's all on the internet. So the way that the internet shifted from just content to applications, we can see a radical shift in blockchains in the same way in terms of the application that they support. If you give them this support, if you give them the ability to use all these languages, if you give them all this throughput. So what does this mean in practice for users and developers? So again, going in the old paradigm of blockchain, I would say censorship resistance is the bread and butter. Why is that? Well, that's why they were invented for. The whole point of the invention of Bitcoin is you want to have a decentralized cryptocurrency, and it needs to be censorship resilient, and it needs to be very, very resistant, because people are going to try to corrupt it. And that comes, at the time, with those systems, with a huge cost. Right? There's a huge cost in running those systems. They're slow, they have high latency, and whenever people have tried to build applications, I would say a very, very good rule of thumb to know if an application was good for a blockchain was like, does this actually need censorship resistance? Are there nation states colluding around the world to stop it? And if not, why on earth are you paying the cost of being on a blockchain? It's a huge cost. It doesn't have that much advantages compared to a centralized database. So why would you pay that cost? But if you reduce the cost, if the cost becomes minimal, if basically you are within maybe 1 order of magnitude, a factor of like 3, let's say, or 4 from cloud cost, then it becomes very different. Then that question goes away. Then it's like, well, maybe I don't strictly care about censorship resistance, but I care about convenience. I care about the fact that payments are natively supported. I care about the fact that people are already onboarded. I care about the fact that they have their identity. I care about the fact that I don't necessarily have to pay the bills for a server, right? It can be paid by customers directly. So there's a lot of small but benefits that completely add up. And if you can get the cost low enough, it truly transforms the type of applications that can be built and that can be deployed on the systems. And so mainstream programming languages is, I think, a super important piece of that. They're used by tens of millions of developers, not tens of thousands. They have better documentation, better tooling, way more libraries, way more educational material. And also, and that's, I think it's, there's a ton of absolutely meaningless drivel and, drivel hype around AI and blockchain. That doesn't make sense. But I will say this, AI systems are very, very good. They're getting very, very good at coding, and they're much better at coding when they have large corpuses. So they are better programmers of Python and JavaScript than they are of smaller languages. And so the pressure, everything that I said about the benefits of using JavaScript and Python is going to keep increasing and increasing as more and more code is being built by AI. So that, I think, is one of the most important reasons for moving to those languages is the tooling is getting so much better and so much more important. So because supports matter, we're starting with JavaScript to open Tezos to tens of millions of builders. And when I say JavaScript, so right now, the project to do it is Justice. And you see, I mentioned a few projects, Etherlink, Justice. Right now, we have a few initiatives, and the goal is for those to coalesce into this big project that is Tezos X. So JSTZ, pronounced Justice, is an experimental rollup that you can try with a JavaScript execution environment. It has a web-like interfaces between contracts, so talking to another contract feels like making a call to a web server, except with atomicity and without the latency and all of that. You can try it now. There's a link and there's a QR code. If you're a developer, please try JSTZ and let us know what you think. One thing, real JavaScript hasn't been tried, so you've probably heard of oh yeah, but didn't they try JavaScript in that project and that project and that project? So yeah, I wonder, because I thought look, JavaScript would be huge. We need to do it, but didn't they do it in way back in what was it called, Links or something like that? No, they only supported a few contracts, and you had to do governance to modify it. Didn't they try it in Near? No, your contract had to carry the entire interpreter with you. So every single blockchain that has done JS, there's always a little fine print. It's not full support. We're going for full support of JavaScript without the caveats, without the fine print. So JavaScript, Python, Michelson, all this VM, all in one big rollup, cheap, fast, always on, with easy integration to existing code, a lot more on-chain logic, allowing millions of users to have real-time experiences. Thank you.